Assalamu alaikum. Good afternoon, gentlemen. Really, it's my pleasure and honor to be with you for today, talking about introduction of Lean Six Sigma. We have, inshallah, 1 hour. We hope we cover the subject as possible as we can. So, starting from Lean history and then from where it started. In fact, Lean is considered a concept of efficient manufacturing, which been born in Toyota production system back in 1930s by Taiichi Ohno. And the concept behind Lean is to eliminate the waste or reducing the waste. So from the early 30s, the initial kickoff of the lean manufacturing started in the 1930s and all the way continues from 1950 until 1990. The Japanese keep continual improving the concept of lean, and early of 90s there was a book being developed by James Womack, and this was the first book being introduced the lean concept and the lean principles. So what is lean? Lean is about focusing on the waste reduction and what is the value to the customer. So what I mean by value is that what the customer is looking for. So that's what we call it a value. We need to emphasize on the value to the customer by reducing the waste, or we can call it the non-value added. Also, another definition of lean is to separate the non-value added from the value added activities. And when we say as a non-value added or value added, always we have to link it with the customer need, the customer satisfaction. From that perspective, we can decide which value is added to the customer satisfaction or which activities are not value added. So how can we identify this? By creating a map, a value stream map, to identify the value steps or non-value added steps and try to eliminate. After we identify the non-value added, we try to make the activities go smooth, no delay on time, no waiting. So this is one of the concept or one of the definition of lean, and followed at the end by the continuous improvement or strive for the perfection. So when we talk about earlier about the waste that's been introduced by Taiichi Ohno, the father of lean concept. So these are the main waste which come under the TIM wood. So starting from the transportation, which mean unnecessary movement of products or materials, and this is considered as a waste that impact on the performance, impact on the processes. Another type of waste is motion, unnecessary movement of people, unnecessary movement by people. Overproduction, you produce more than needed by the customer. That's considered as a waste and losing money. Defects also considered as like rework. If the product been defected, then you have to rework, and this is considered as a waste, which will impact overall profitability and causing a problem to the organizations. Also, the fifth one is the inventory. Excess raw material. Access of the inventories is considered as a waste, and that should be avoided. Also, for waiting time. Waiting time is one of the most waste being absorbed among the organizations. Waiting arrival, waiting delivery, waiting approval. And these are really, all of these 8 deadly waste is very critical to implement lean concepts. Overprocessing as well is to do the step twice instead of do it once and it goes fine, it goes perfect. However, for some reason, you've been doing again and again. That's we call it overprocessing, which is unnecessary activities, which is considered also as a non-value added activity. And the latest one is the skills, unutilized people's talents. For example, if we have a person in our organization where he have the a certain type of skills, if we are not utilizing these skills at the right position, it's considered as a waste. So in summary, all these waste has to be prevented in any organization, regardless. It is manufacturing, healthcare, industrial, regardless of any organization, these 8 deadly wastes should be eliminated if possible. If not, then we have to reduce it as minimum as possible. Okay, then we will come up to the lean principles, where we talked earlier at early 90s. There is 3 authors stayed in Japanese for a couple of years, evaluating the performance of Toyota production system, trying to understand how Toyota production system became the best manufacturing of cars, even after the World War II. So the result of these authors, they developed a book where they mentioned for the first time the details of the principle of the lean. So started from the principle, one is define value. Define the value from the customer perspective. What customer is looking for? For example, if we talk about delivery time, so the customer, he wants to receive his product on time. So this is considered a value to the customer. We should not be delay, or we should not be late on the customer itself. Then once we identify the value, we'll go to the next step, is to map the value stream. Mapping the value stream mean to put all these steps required from A to Z, from beginning of the product until the final product, from the supplier to the final product. Once we draw all these requirements, then we can identify where is the value added and where is the non-value added. So how can we identify the non-value added? We go back again. We look for any waiting time waste. We look for unnecessary motion. We look for any defect in the processes. Do we have any inventory issue? So we have to link always the 8 deadly waste during creating the value stream map. So once we create the value stream map, we'll go for the 3rd step, which is creating the flow. You have to draw a timeline or draw a steps beginning point to the end point. And then you will establish pull system. Pull system mean based on customer demand. If customer demand 3-piece, then you have to produce 3-piece only. You should not produce over than the customer requirements. And the last principle is pursue for perfection, which means continuous improvement. So you have to have a continuous effort toward perfection. So in summary, lean is a culture. Once it's been implemented among the team, over time, the people will be capable to speed up the process and eliminating the waste. This is an example of the value stream map. As we said that the value stream map, it's allowed the organization to create a detail visualized about the steps being done during the work processes. Here is an example of one of the manufacturing units where they have main steps: mailing, welding, and benting, and assembly inspection. Finally, it goes to the customer. So these steps are the main steps. So when we create the value stream map, we begin from the supplier, from the inventory. Are we receiving material? So it will go to the first step, mailing, then it will go to the second as well. So once we put the steps, all the steps we know it into our process, we start measuring the time for receiving the material, measuring the time for the mailing activities, measuring the time for the welding, how much take time, okay, as well as benting and assembly as well, until it's reached the final customer. So once we set up the time, we can identify where is the non-value added, or where is the wasted time. Now let's see. The mailing activity, the activity itself, it just takes 2 minutes. However, from the first step to the second step, it's required 10 days. So this is considered a waiting waste. So we may sit as a team to discuss the value stream map. We can reduce these 10 days. We can make it 8 days or 5 days. It's about the team discussion and the decision, what is the best time interval in between. Similar to the waiting time between welding activity and the benting. These 12 days is not a value to the customers. Customer value, he's looking for maybe benting, maybe the assembly of the part being well assembled, so the customer will not complain about the assembly issue. So this is the way how to draw the value stream map in summary, because there is a special training of developing the value stream map. Okay, here is an example of the Formula One tire replacement. Back in the 80s or 70s, the average time for replacing the tire was on average 55 seconds to 65 seconds. And after Ferrari team implement the lean concept, they brought the time up to 1.9 seconds. Now we will watch the video together, and hopefully we can see how they go for tire replacement. Now you can see even the readiness. The readiness of the position of the people already. Everyone is holding activity, a certain type of activity. They are waiting just the stop of the Formula One. See, it is just 1.9 seconds. I will try to repeat it in quickly. See. So what we saw just a couple of seconds ago, the focus and the all the activities are value-added activities. None of them is doing something, is not adding value. So this is just an example. Now this is like a value stream map with color coding. If we can see the green colors, their job only just to remove the tire. The blue color, his job is just to loosen the bolts. So once bolt is loosened, the green person will take the tire, and the orange one will install the new tire. All of them are doing the same activity at the same time. Or sorry, doing the different activity at the same time. like synchronization. These with two red color, just lifting the car, and these four yellow persons are just holding just for balance. So we can see that there is zero non-value added. And how they achieve this progress, it is through a long workshop at trying to identifying the waste that caused the delay. So why they go up to this approach? Because at the Formula One racing, the time is fatal to win in the competition. So delay 5 to 10 seconds, you may lose the racing, or you lose the position one. That's why the value for them is the time. So they want to speed up the time as maximum as possible. Okay. One for the last is the BDCA method is considered one of the problem-solving methodologies, which have been introduced by Edward Deming back in the 1960s. And it is very simple method, part of Lean concept. Over time, you have a quality improvement. So if you do a minor improvement, you plan or you define what you want to improve, you measure it, you analyze it, and then you take action to improve the situation. Then you verify your action. Is it being satisfied or not? Is it achieved your desired or not? Then you will just control it or act on the solution that's been developed in order to sustain the performance. So you have to standardize it with a procedure, you have to standardize it with a system in order to avoid the problem to reoccur again. So over the time, you will have a quality improvement into your organization, and all of this is part of the continuous improvement. Okay, now we'll move to the Six Sigma concept. So what is Six Sigma? Six Sigma is a set of tools being given to all organizations, to any organization, to improve the process capability, reduce the variation of the processes, reduce the defects, also to improve the profitability and the quality of products or services. So Six Sigma here is applicable to any organization. Any organization want to improve their profitability, or if they want to reduce their cost. So Six Sigma is the best solution to follow. Also, Six Sigma in quality, it is also used as an indication that the process is well controlled within the specific range being given, which is, let's say, 3 sigma to the left of the center and 3 sigma to the right of the center. Here is just a visual example. Let us assume an example here that the delivery time, the customer expectation is to deliver within 1 day, which is the not less than 1 day. We can call this limit lower specific limit, and we can call this as an upper specific limit. So the customer satisfaction, let's say, as an example, not less than 1 day, not more than 3 days. Let's assume that this is our specification. So the next step, when we collect the data for, let's say, 1 month history, and we did the analysis through the Minitab program. Minitab program is a statistical software, help you to do the statistical analysis. So if the data being collected, let's say for 1 month, to measure our capability to meet the target, to be within the specification being given. So look at the green graphic or the distribution in the green color. If all your data fall into between these two specific limits, then only your process capability considered as a Six Sigma capability. That's mean in 1 million opportunity, you will have only 3.4 defects. So let's say if you deliver 1 million products, you may have delay on just three products. Let's assume like this. So look at number one. Most of the data is just across the upper specific limit or less than the specific limit, which is indicating that there is a huge defect, huge meeting the customer expectation, because the customer expectation is to deliver the product within 1 day, not less than 1 day, not more than 3 days. So these data, which is exceeding the upper specific limit or exceeding the lower specific limit, is considered as a defective. So there is a problem here where we need to investigate, we do some analysis in order to improve the process capability and reduce the variation. So we want to make the curve, instead of widely like 1 and 2, we want to shrink it and make it narrower. So all your data, which is like say in the green color, will be within your specification limits. So this is also another example similar to the other one. The blue color, all your data is fall within the specification limits, the lower specification and the upper specification. Look at the green one. The green one, most of your data is within. However, there is a certain time that you be delayed. You exceed more than 3 days, which is not meeting the customer satisfaction. And also, some of your data, which is located here, it may over time also exceed the upper specific limits. That's why in Six Sigma, always we want to assure that the distribution is narrower. So even if there is a process variation to the right or to the left, we will still be able to control the process and we will not exceed the specific limitation. So always we need to avoid the red curve, we need to avoid the green one, and always we need to focus on how to move our process capability to the blue curve, which is all your data are centered and within the specification limits. And that's why Six Sigma is focused on the variation, because these are the variations. When you variate your process above your specific limits or lower than your specification limits, that's a big problem, which is against the customer expectation. Okay, Six Sigma in history. Originally, it's been started on the Motorola, where the CEO Bob Galvin, once he gave a challenge to his technical team to show an improvement. So there was an engineer, his name is Bill Smith. He worked with the Michael J. Harry, to develop the statisticals and the Six Sigma methodologies. Okay, and later on, in the 1987, Six Sigma became a trademark for Motorola. And then Bill Smith, he passed away in the 1991, early 90s, where Dr. Michael Harry, the co-creator of the Six Sigma, he was one of the team who leading the development during execution back in the 80s. And it's been popularized by Dr. Michael Harry. And Dr. Michael Harry, he is the one who created the DMAIC roadmap for define and measure, analyze. The 5 steps of Six Sigma has been developed by Dr. Michael J. Harry. Also, he is the one who developed the certification of the Six Sigma, Lean Six Sigma. the yellow belt and green belt, black belt. This is the first ever black belt group in the Montreal being trained by Michael J. Harry back in the 35 years. And this is the first book being introduced for Six Sigma, explaining the Six Sigma strategy and how Six Sigma can do a breakthrough improvement. Okay, so how does Six Sigma solve the problems? Initially, we took a practical problem. For example, there is there is off-spec product causing a customer complaint. We took the problem that arose into the organization as a problem, as a statement. There is a delay on receiving the product, or there is a delay to send the product to the customer. So we took the existing problem. Let's say we have high cost, for example. We have high cost, which is a problem to the organization, and we need to reduce the cost. So initially, we stated the problem as a practical problem, which is the current situation. Then we will turn this problem into statistical. We're going to use the data, we're going to use the statistical analysis in order to understand the problem, to understand the behavior of the performance. So once we analyze, also using the statistical solution. So all these steps are being done through Minitab system or Minitab software. So once we brought the statistical problem, then we try to find a statistical solution, find out the correlation between the parameters or the indications that we have. Once we find out and prove by statistics that the solution is related to this problem, then we will find a practical solution to control it. Like we develop procedures, we train the team, we make solution as a practical that can be implemented. This is just in summary on how the Six Sigma is solving the problem. This is very important equation. We will talk about it in the next slide. So this also another Six Sigma methodologies. The main known as DMAIC strategy or DMAIC methodology that's been developed by Michael Harry, where it is a start from defining the problem, measuring your data, analyze them, find out solution in order to improve your process, and then you control it. This will be used for the existing product, existing process, which is the most popular methodology being used for Six Sigma. The DMADF or DMADV is also used in existing products or processes, but a little bit wider. It's for exceptional improvement. You need to design the solution and you validate the solution before you implement. And the IDOV is only being used when there is no product or process. Let's say designing stage or designing phase, we could follow the IDOV. Okay, this is a simple explanation about the DMAIC. Define the problem, exactly what is going on, what is the problem, since when the problem is occurring, where the problem is being occurred, and there is many requirements in the define phase. The second step is the measurement. You have to measure the gap between the current situation and the desired target. You need to find a baseline to understand what is going on currently, and then you will move to analyze your data that's being collected. You will analyze it, try to identify the factors that need to be adjusted or eliminated in order to solve this problem. Finally, when the improved, the solution being found and the situation being improved, we will go for control the improvements that have been made. So whatever desired situation that we achieved, we need to assure it has been sustained and the problem will never occur again. So this is what we mentioned as we talked earlier, that defined that we should mention what is the problem, when did it happen, where the problem has been occurred, and what is the business impact, how much cost money, or it is impacting business reputation. You have to mention what is the impact over the business. So in the measure step, in the measurement, we collect the current performance as a baseline. We verify the data being collected. We assure that the data being collected is accurate, and we can trust on this data in order to go for analyze. This is very important step to measure your data and verify the accuracy and the precision for your data. And third step is analyze, where you're going to analyze using Minitab, trying to identify the causes of process variation and try to correlate the findings that you observe. You try to correlate it with the problem that it's been noticed. So by statistics, you can find out a solution. You can find out which parameter need to be adjusted or which action need to be taken in order to solve the problem. So once been improved, the last step is to control that improvement. So we will avoid the reoccurrence, and the process will be stable and capable to meet the target, which is always we look to the customer perspective. So what Lean Six Sigma methodology can do? Six Sigma is a structured problem-solving method which will guarantee to any organization to aspire better achievement and to have breakthrough improvement from different perspectives. So the why, this is equation, we call it underlying mechanics of Six Sigma. This is very essential into the Six Sigma. So the why is the outcome effect. The why is the need of customer, or the final result, the final product. And it is consist of many parameters. For example, if we talk an example here, let's talk about the coffee, a cup of coffee. This is the final result. The final result that the customer is looking for is very good taste of coffee. So this is the final result, which consists of many parameters. So when you look at the parameters, it is a water temperature, for example, water quantity, the sugar or not without sugar. So all these steps being created in order to have the final result or the final product. So any change in the quantity of the water, for example, or the temperature of the water, any change of this parameter will impact on your final result. So this is equation is common, and it is applicable to any process that we have it, regardless it is manufacturing or services or products, because it is applicable and it's easy to understand and grab the situation. So the Six Sigma also can be driven from the top management, the buy-in from the leadership team into the organization, from top to bottom, and the improvement will come from bottom to top. So you will improve your processes, you will reduce your variation, you reduce your defect, you made your process within the control limit, meeting the target. So this will enhancing the operability of your organization, and ultimately it will achieve your business company objectives or business strategy goals. So here, let's say an example here. Let's say that there is a company doing very well. Let's say they are doing very well in controlling the cost. Okay, let's talk about cost here. The cost is very controlled in a good manner way, and it is showing a very improvement manner. They are doing good here. So if they implement a Lean Six Sigma, they will move a breakthrough improvement. This is the power of Six Sigma. So it is not necessary that an organization have a problem and only we will use a Six Sigma. It's not only in this case. So for example, if you have a company, they have a problem with the high cost, for example, or they have a problem in the quality of the product. They can use Six Sigma. But now I'm talking about a company that they are happy with the current situation. They are meeting the target and everything is within the range. However, if they implement a Six Sigma methodology, they will make tremendous improvements into their organization. So it is very essential for any organization to achieve a better result. So how we implement the Six Sigma projects. So the starting point will be from the voice of customer feedback. This is very important to understand the customer need, to understand the customer feedback, because at the end, customer is the essential to maintain your sales. If the customer rejects your product, it's a matter of time, then your organization will collapse and you will go out of market. That's why it's very important to bring the findings or the gaps being identified from the customers in order to solve it by implementing the Six Sigma. Also, another source is the financial performance. Let's say we observe a financial performance, we observe highest cost, or we observe a problem in the finance reports. So from there, we can take this problem and we turn it to the project. Also from the operational performance, the production example, or the benchmarking. For example, if one company did benchmarking with other similar companies, so they identify there is a gap, so they want to improve further. They are not satisfied with their current situation. So also this is another source to collect or to identify the gap or identify the problems. Then it will go for, let's say, in the corporate level, which is the executive level or the owners of the organization. They will look at it, the profitability. Is it impacting the profitability? Is it impacting the capability? That means we are not meeting our target all the time. Or it is based on cost and we need to reduce the cost. So whatever the management, once they agree, the decision on this action will be taken, that yes, it is a problem and we need to solve it. Then it will go to the second level, which is the business unit level, or the site, or the place where the activity is being done. So you will start designing the processes, and you will start put the project leaders for each problem. Each problem there will be a leader to look after, and each leader have a team to work together and apply the Six Sigma methodology in order to achieve the final result that the team is looking for. So this is just a project overview. This as an initial view. So is the current situation before you start the project, and the odds is what you want to achieve. So if you have a quality issue currently, so you want to achieve on spec quality. You want to achieve the best result in quality. This is what you want. And there is a gap. So that's why you will follow the Six Sigma in order to move from the current situation to the desired situation. So starting from the scope of the project, how big the project, which area going to be included into the project to solve the problem, and which area is not going to include it as well. Depth of the problem, how severity the problem it is. Critical to quality, which is parameters that direct impact on the quality. Verify the history. Is there any data? You have to collect it. The measurement system, you have to assure that your data is accurate and normal without any defect. A team has to be selected from the department or from that organization, and they will assign to focus on solve the problem. The sponsor, the leadership has to be there to support the execution. And finally, the CTQ can be also translated to the money. For example, the quality of a spec can be calculated in a way to understand the money losses, or maybe time losses if it is the value. So always we will look at the value perspective from the customer perspective. This is a simple example of project charter. You put the name of the process that you want to improve. You have to build your business case. You have to build a case that you convince the owners of the organization or the leadership of the organization that there is a problem and it is causing money loss or causing a problem. So you will get the leadership attention to begin and support. So here is the opportunity of problem statement. You have to mention it, what's happening, where the problem is happening, when it is happening, and what is your goal, what you want to do. You want to improve the quality by 2%, 5%. You want to reduce the cost by 20%. So you have to state the goal statement. Here is the project scope, where to focus, where to look at, and out of scope that we should not look at it, which area or which system that we are not going to analyze. Okay, and here the team members of the projects and the timeline for define phase. Let's say define phase will take 1 week or maybe 3 days, 4 days. Measurements, you have to specify how many days you will spend on measuring, and this is like a timeline until you reach the control status. Okay, this is very important concept, which is critical to quality, or critical to delivery, or critical for pricing. So always we look, as we said earlier, from the customer perspective, the customer satisfaction. So the customer need that he want the best quality, he want the fastest delivery, and he want the lowest price. So this is mostly what customer is looking after. So in the quality, if you have an issue of quality and you are not meeting customer satisfaction, then you need to defect free. You need to reduce the defect. You need to improve your quality in order to meet the customer satisfaction. For example, here, if you have a delivery issue, let's say you are taking long time to deliver. So here you're going to do a cycle time reduction. You have to reduce the time in order to deliver as per the target. Also for the cost and function, if the price is high, which is not meeting customer satisfaction, then you need to do analysis and try to figure out how to reduce the cost in a way that you will meet the customer satisfaction. So, and the critical to quality, it could be 1 or 2, it could be 10, it could be 50 critical to quality. For example, if we talk about electronic company on producing the laptop, for example, they have thousands of critical qualities. The USB charger or the battery or the keyboard, whatever electronic part is critical to quality of that laptop. So any damage, it will impact on the quality of that laptop. That's why maybe electronic companies, they have more than hundreds or thousands critical to quality. But if we talk about, for example, a restaurant or a coffee shop, you may have only 5 to 6 critical to quality. As we said, the critical to quality is a step or an action that will direct impact to the final quality or final product. Okay. From the perspective of ISO, there is a standards being developed back in 2011, which explain the quantitative methods of Six Sigma, and especially focusing on the mic only. What to do in the define phase, what to do in the measurement phase, analyze phase also, until you reach the last one is the control. So as per ISO standard, there is detailed explanation, and it is very important to read it and follow in order to achieve the best in class. The second ISO standard is 13053.2. The first one is 53.1, and the second one also produced in the same year, 2011. Here they mention the Six Sigma plus part of the Lean concept. And unfortunately, I will utilize this platform to just give advice to the people whom interest to learn Lean Six Sigma methodologies. Some of the training center provider, they provide only 2 days or 3 days, and they will give you a green belt certification. Believe me, if you take less than 40 hours in green belt, you cannot implement a project in your organization, because there is a requirement. There is many things to be learned, many things to be trained into in order to have full knowledge of the implementation. So you cannot have the black belt if you take a training for 1 week, 40 hours or 30 hours, and you'll be certified as a black belt. At the end, you will have just a name that you'll be certified as a black belt, but in reality, you cannot execute. Why? Because you did not complete the minimum hours as per the ISO standards. So we need to take care about the right training in order to have full utilization of the Lean Six Sigma implementation. This is just a summary of the integrated both discipline. So in summary, Lean is improving the focus on improving the efficiency, where Six Sigma improve the effectiveness. Lean is focused on improving the workflow, make it more speed workflow, less non-value added. Also for the Six Sigma is to reduce the variation into your process. In Lean, we have to eliminate the waste if we can, or at least we reduce them to the minimum as possible. For the Six Sigma, we are looking after the defective or the defect. And for the emphasize, both are looking for the customer perspective as a Lean and Six Sigma. All the values here and there is just for a customer perspective. Here is some tools being used in the Lean, which is 5S methodology. Muda is a Japanese word for the waste. It is the same meaning. Kaizen, Kanban, value stream mapping, these are tools and techniques can be followed during implementing Lean projects. Critical to quality, CTQs, defects per million of opportunities, and many others. This is just a summary. We are limited with the time. We cannot explain in details each step. And latest one is common tools that being used in both, like cause and effect diagram, process mapping, standardized work, logic tree, fishbone also. And also there are many others that can be used in both disciplines. Thank you, gentlemen. Hopefully I cover within minimum hours. Thank you very much.